Integration by substitution, I will focus on one main aspect in this section, and that is that it is possible to integrate by using a substitution that we call a UDU substitution. I think that's the main thing. We talk about the change of variables. Um, Personally, I do not change the variables. I do convert to a UDU substitution, and then after that, I go back to the original form. So there are no need to change the variables in the sense of what they're talking about. There is a change of variables for the UDU form. That is, that if there is in the integral or the integrand an expression, and if its derivative is also, or some form of the derivative is also within the integrand, then we can use the UDU substitution. Obviously, we're changing the variables. But in terms of the evaluation, we will do the evaluation based on the original form. We'll go back and back substitute, if you will. And so working some problems here, I think you'll get the idea of what I'm talking about. So that's what he means there by the change of variables, blah, 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 blah. Again, he's using the change of variables to calculate, if you will, the definite integral. I will show you how I do it, and I think it's just very straightforward without all the hoopla. Integration of even and odd functions. This is pretty interesting. If you know that the function is even, then instead of doing the evaluation of the upper and lower limits, you just take 2 times the integral from 0 to a, f of x dx, and you get the result. If you know that the function is odd, integrating over an odd function is going to give you 0. Basically, the integration is said to be the area under the curve. So if it's even, it's symmetric. So 1/2 of the curve, that area is the same as the other half. So just say 2 times a half, and you get what you want. If it's odd function, so that tells you that part of the function is occurring in the odd or the negative quadrant. Half of it is in the even quadrant, and the other half is in the odd or negative quadrant. And so when you add both of those, the areas cancel out. You get 0. So that's what he's talking about there. And then my note there at the bottom, I just told you that in the beginning of my talk. Let's look at some problems without hesitation. So what we understand with the UDU substitution is that you look at the integrand, and if you see in the integrand an expression, and if you also see its derivative or part of the derivative, then we use UDU substitution. Here's what I mean. Look at the x cubed minus 1. Don't worry about the 4th power yet, but the x cubed minus 1. Take its derivative, and that gives you some form of x squared dx. You got it. Let me show you. Let u equal to x to the 3rd minus 1. Then du is 3x squared dx. So that is that 1/3 du will represent for us x squared dx. That's also in the integrand. So I took my sins and put them in a bag. Then he closed up the bag. So this is, now think about it, that x squared dx is represented by 1/3 du. So we can put, you know, constants in the front of the integrals. This is 1/3 times the integral of here. I have x cubed minus 1 to the 4th, but that's u to the 4th. Now the 1/3 du takes into account the x squared dx. 1/3 du is, right, the x squared dx. And then here the u is being represented, well, the x cubed minus 1 is being represented by the u. So we just integrate this, and so that gives us 1/3 times u to the 5th all over 5. Don't forget your constant, since this is an indefinite integral. So we have u to the 5th all over 15 plus the constant c, and u, go back, we back substitute. So u is the x cubed minus 1, and that's to the 5th power over 15 plus c. U du substitution. It's very straightforward. Let's try this one. So here, notice that the 5x squared plus 4, its derivative will be some form of the x dx. So let u equal to 5x squared plus 4. So du is 10x dx. So 1 over 10 du is x dx. So we have 1 over 10 times the integral. The x dx is here, and so that's the 1 over 10 du. We'll put the du at the end, and this is u to the third, right? So we integrate, we do not hesitate. So this is 1/10 times u to the fourth over 4 plus the constant. So this is u to the fourth over 40 plus c, and the u is this 5x squared plus 4. So this is 5x squared plus 4, and that's raised to the fourth power divided by 40 plus c. And don't forget the constant of integration. That's important. Okay, so it's more of the same. Let u equal to what? U squared? No. U cubed plus 2. Everything in the integram must be represented by some type of substitution, right? So if u is, look at this, is u cubed, oh, sorry, they got u, we can't use u for u. Stupid problem, right? So let v, hopefully my v does not look like a u. So then dv is 3 u squared du. Now in the problem we have u squared du. So obviously the 1/3 dv represents u squared du. He took my sins and put them in a bag. And then he closed up the bag. He sealed up the bag. Thank you. So 1/3 dv will represent the u squared du. So 1/3, this is the integral of, here, this is the square root of u cubed plus 2. This is the square root of v. And here, this is dv. And we can write this. This is the integral of v to the 1/2 dv. So now we integrate. This is 1/3. Here we have v to the 1/2 plus 1. That's v to the 3/2 divided by 3/2 plus the constant. Did I put the constant up there as well? I did. So the 2 goes up top. So this is 2 over 9. And the v is the u to the third plus 2, and that's raised to the 3/2 power plus the constant. That's the answer. Okay, this one, look at that x to the fourth, or 1 plus x to the fourth. Its derivative will give us x to the third. So here, let u equal to 1 plus x to the fourth. Du is 4x to the third dx. So 1/4 du picks up 4's for the numerator, x to the third dx. Anytime you have a du, your dx has to be, the form thereof has to be in the numerator. We do not talk about, and it's not defined to have, for an integral, a differential in our denominator, to say something like 1 over dx to integrate that. We don't know what that is. I don't know what it is. So the 1/4 will go in the front. This is the integral. Now notice that x cubed dx is the du 1/4. So we can just, x cubed dx is there. So that's just du up top. All over the u to the second. Okay. So this is 1/4 times the integral. I'm going to write it like this. This is u to the -2 du. So we integrate. This is 1/4. We do not discriminate. We integrate. So this is 1/4 times u to the -2 plus 1 is -1. That's divided by -1 plus some constant. Let's clean that up. This is -1/4 times 1 over u plus c. So this becomes -1 all over the 4 times the u, and u is 1 plus x to the 4th plus c. Let's go a little further. Again, still more of the same. Notice that is that a pen? Oh, the x to the 4th, 1 plus x to the 4th can be represented by u. Let u equal to 1 plus x to the 4th. So du picks up here. This is 4x to the 3rd dx. So 1 over 4th du is x to the 3rd dx. So we come here. This is the integral of 1 over 4. The integral x cubed dx is the 1/4 du. So we have du sitting there. And this is all over here, the square root of u. So let's write this as 1/4 times the integral of u to the -1/2 du. And so this is 1/4 times u to the -1/2 plus 1 is 1/2, and that's divided by 1/2 plus some constant. So the 2 goes up top, so it's 2 over 4. We get 1/2 times the square root of u plus c. But u was this. So this is 1/2 times the square root of 1 plus x to the 4th, and then plus c. Find the indefinite integral and check the result by differentiating. We just integrate. Good to check it. You always check it to make sure you got the right result. So this is 1 over, I'm going to pull out the square root of 3 because it's a constant. It's the integral of 1 over the square root of x dx. Well, the interesting thing here is that there's no u du substitution. We just integrate directly. So why is this problem even in this section? I don't know why. This is the integral of x to the -1/2 dx. That is a good question. Why is this problem here? Okay. So the coefficient stays the same. We integrate that x to the -1/2. That becomes x to the -1/2 plus 1, x to the 1/2, and that's divided by 1/2 plus some constant of proportionality. So we have 2 up top over the square root of 3 times the square root of x, or x to the 1/2 plus c. And you can rationalize that denominator, so you can have 2 times the square root of 3 over 3 times x to the 1/2 plus c. It's like 4 or 5 ways you can write the answer. You know, you can put that x with the radical, if you will. Say this is 2 times the square root of 3x all over 3 plus some constant. So whichever floats your bubble, whatever that means, right? Or that, doesn't matter. This next one, here you want to actually evaluate the definite integral. Use a graphing utility to verify your results. I don't think we have to. You just integrate. Now, for this, you definitely want to be able to see the u du substitution. Fascinating. Simple. Let u equal to (6x plus 7). So du is 6 dx. So we got to represent the dx. We can do that by saying 1 over 6 du is equal to dx. So here we have 1 over 6 times the integral from 3 to 7, and this becomes 1 over the square root of u, and 1/6 du picks up the dx, right? So we simplify this. This is 1 over 6, the integral from 3 to 6 of u to the negative 1/2 du. So now we integrate. So we get 1 over 6 times u to the negative 1/2 plus 1 is the 1/2 divided by 1/2. This is evaluated from 3 to 7. I don't know why it became 6 there. Oh, I'm looking at that 6 right there, probably. Let's clean that up. This is 2 over 6, or 1/3, times the square root of u. Let's go ahead and put one, just leave it there. Evaluated from 3 to 7. That u is 6x plus 7. So this is 1/3 times the square root of 6x plus 7. And here we're evaluating that from 3 to 7. So we get 1/3 times the square root of 6 times 7 plus 7 minus 1/3 times the square root. Use the first fundamental theorem of calculus to do the evaluation. And so this is 6 times 3 plus 7. So we have 1/3 times the square root of 6 times 7 plus 7 is 49, minus 1/3 times the square root of 18 plus 7 is 25. So it gives us 7/3 minus 5/3. We get 2/3. Exactly what the doctor ordered. Well, that's all that I have for you for this section. Most important section in calculus, particularly for integration. U du substitution. You got it.